Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in calculus, particularly on the application of slope or derivative of functions interpreted as slope of tangent to the curve. So allow me to present the solution in this manner, less animations, because the problems are basic ones, and I just hope that you can follow the presented solutions and the explanations. So here is the problem. Find the slope at the point indicated. These problems are taken from the book by Love and Rainville, and the numbering is also the same. So number 1, y equals x squared minus 5x plus 4 at the point 1 comma 0. Take note that when x is 1, y is equal to 0. So 1 squared minus 5 times 1, negative 4 plus 4 equals 0. So these points are on the curve. So m is slope is derivative of y with respect to x, and the derivative of x squared minus 5x plus 4 is 2x minus 5. Then since x is 1, 2 times 1 minus 5 is equal to negative 3. So this is the slope of the tangent to the curve, negative 3. Problem 2, y equals 7 minus x squared plus 4x cubed at the point negative 1 comma 2. So dy dx slope is negative 2x plus 4 times 3, 12x squared. So the slope expression or the derivative of y with respect to x is negative 2x plus 12x squared. Substituting x equals negative 1, so slope dy dx is negative 2 times negative 1, which is positive 2, plus 12 times negative 1 square, which is positive 12. So 2 plus 12 is 14. So the slope is 14. Number 3, we have derivative of fractions. So remember the technique. It is denominator. So slope dy dx denominator times derivative of numerator, derivative of x with respect to x is 1, minus numerator, which is x, times the derivative of the denominator, which is 2x all over the square of the denominator. So all over quantity x squared plus 4 square. Simplifying, x squared minus 2x squared is negative x squared. Then we have 4, so that's why it is 4 minus x squared over quantity x squared plus 4 square. Substituting the value of x, which is equal to 2. So 4 minus 2 square, which is already 0, over 2 square plus 4, 8. 8 square is 64, but 0 over 64 is still 0. So the slope of the tangent to the curve y over x squared plus 4 at the point 2 comma 140 0. Number 4, y is, again, we have fraction here, y equals 1 minus 3x plus x to the 4th over x cubed, so that we can evaluate the derivative conveniently. We have to perform the division first. So 1 over x cubed, so 1 minus 3x plus x to the 4th over x cubed. 1 over x cubed is x to the negative 3. Negative 3x over x squared is negative 3x to the negative 2. And x to the 4th over x cubed is x. So dy dx, the derivative of x to the negative 3 is negative 3x to the negative 4. Then negative 3 times negative 2 is 6. Then x to the negative 3, negative 2 minus 1. So positive 6x to the negative 3. derivative of x is of course 1. So slope dy dx, transforming this into an expression or terms such that the exponent is positive. So we have negative 3 over x to the fourth plus 6 over x cubed plus 1. Then we substitute the value of x, which is 1/2. So slope is negative 3 over 1/2 to the fourth, and this is negative 48. Negative 3 times 16, so negative 48. Then 6 over 1/2 cubed, that's positive 48. So negative 48 plus 48 is 0, then plus 1. So the slope is 1. So slope dy dx, negative 48 plus 48 plus 1 is 1. Number 5, y equals x cubed plus 3x plus 14, where the curve crosses the x-axis, or OX. The point where the curve crosses OX has y coordinate value, which is 0. So if y is 0, we have to find the values of x. So this is the original curve or equation, y equals x cubed plus 3x plus 14. So since we find the slope of the tangent where the curve crosses the x-axis, and those points have y coordinate 0, so that's why we equate y equals 0. So 0 equals x cubed plus 3x plus 14. And since your calculator is allowed here, so finding the roots of this cubic equation, in fact, the allowed calculator is also capable of evaluating roots of a quartic equation. So this is only cubic, so x is negative 2, the other roots are complex conjugates, so this is the only real root. Therefore, we find the slope of the tangent at x equals negative 2. So slope dy dx is 3x squared plus 3, and x is negative 2, so 3 times negative 2 squared, which is 14, plus 3 is 15. So the slope of the point on the curve where it crosses the y-axis is OX rather, or the x-axis is 15, or the slope of the tangent where y is 0 is 15, and x is negative 2 at that point. Then lastly, number 6, y equals 2x to the fourth plus 3x cubed plus 2x squared minus 1, where the curve crosses the x-axis. Again, we find the values, the roots of x where y is 0. So this is the equation, we equate it to 0, and we find the roots this time by synthetic division. By the way, my calculator is only capable of evaluating cubic equation. Your calculator there, if it is capable of finding the roots of quartic equation like this, then you are allowed. But allow me to find the roots using synthetic division. First, I'll collect the coefficients of the terms in descending order. So 2, 3, 2, negative 2, 3, 2, there's no x, so 0, then negative 1. I first divide everything by 2 so that this reduces to 1, 3 halves, 1, 0, then negative 1 half. The possible roots are the factors of negative 1 half. So remember from algebra, the roots are possible roots are factors of this constant term. So which are 1 half, which are 1, 1 half, negative 1 and 1 half, 1 and negative 1 half. So that's all. So I'll try negative 1 first. So remember that we have to bring this down, 1. Then negative 1 times 1 is negative 1. Put it here, then add. So 3 halves minus 1 is 1 half. Then 1 half times the possible root negative 1 half is negative 1 half. Then 1 plus negative 1 half is positive 1 half. 1 half times negative 1 is negative 1 half. And 0 plus negative 1 half is still negative 1 half. And finally, negative 1 half times negative 1 is positive 1 half. Since it adds 0 here in the last part, so that means x equals negative 1 is a root. Then I'll try 1 half. So bring down 1 again. So 1 times 1 half is 1 half. Then 1 half plus 1 is 1. 1 times 1 half is 1 half. Then 1 half plus 1 half is 1. Then 1 times 1 half is positive 1 half. That's why negative 1 half plus 1 half is 0. So since this is again 0, 1 half is also a possible root. The meaning of the remaining terms would be x squared, because originally it is 4th degree and we already found the two roots. So this reduces to 2nd degree. So x squared plus x plus 1 equals 0. Since the discriminant b squared minus 4ac, 1 squared minus 4 times 1 is negative, in particular negative 3. The discriminant is negative 3, so that means there's no real roots for this remaining factor. So the real roots are only negative 1 and 1 half. So slope, the derivative of y with respect to x is 8x cubed plus 9x squared plus 4x. So substituting for x equals negative 1. So m1 equals 8 times negative 1 cubed, which is negative 8, plus 9 times negative 1 square, which is positive 9. 9 minus 8 is 1. And this is 4 times negative 1, which is negative 1. So therefore, 1 minus 4 is negative 3. So the slope at the point negative 1 comma 0 is negative 3. Then at the point 1 half comma 0, the slope is 8 times 1 half cubed, which is 1, plus 9 times 1 half square, which is 9 over 4. So that becomes 13 over 4. Then plus 4 times 1 half, which is 2. 13 over 4. So 1 plus 9 over 4 plus 2. That's 4 plus 9, 13 plus 8, 21. 21 over 4. So the slope at the point 1 half comma 0 is 21 over 4, or 5.25. So that's it for this video. I hope that you are able to understand the explanations and the solutions. So take note that these are basic derivative operations, and the slope interpreted, the derivative is interpreted as the slope of the tangent to the curve.